All right, folks, let's jump into page 2 of section 1.3, and we're going to start with some new definitions. This time we're not measuring center, we are measuring spread. So we have some measures for the center of a distribution now. We're going to introduce some measures for the spread of a distribution. So first let's talk about range. Range is the maximum value minus the minimum value for a set of quantitative data. So again, that is a measure of spread. Now we're going to introduce two ideas called quartiles. And these really aren't spread. They don't tell us so much about the spread by themselves. They really tell us more about position. And the first quartile, the definition is, if the observations in a data set are ordered from lowest to highest, the first quartile, Q1, is the median of the observations to the left of the median. Q3 is basically the median of the observations to the right of the median. So really what they do is Q1 marks the position that contains 25% of the observations to the left, and Q3 marks the position where there are 75% of the observations to the left. I would like to make an additional comment about Q1 and Q3. And I'm actually going to scroll down to the bottom and pull out some text here for you to copy down. The definition we use for Q1 and Q3 are the ones at the top of the page, and those are from the textbook we're using. Some textbooks and software programs use different definitions, so you might get different values for Q1 from your calculator than you get from Microsoft Excel, and that's because they're using different definitions of the quartiles. Now, they should be really close. They shouldn't be off by too much, but they could be different. I'll also tell you that the Ti-Nspire CAS calculator uses the same definition that our textbook uses, so I'll show you an example of that here shortly. All right, back to these definitions. The next definition we have is interquartile range, or IQR. That's abbreviated IQR, and again, that's a measure of spread. And what it tells us is the range of the middle 50% of the data. We find that by taking the value for Q3 and subtracting Q1. It's a very simple calculation. Next, but not least, is the 5-number summary. The 5-number summary of a distribution basically it just tells us it's a description of the distribution with numbers. The minimum value, the Q1, the median, Q3, and the maximum. And I know right now you're asking yourself, why on earth do we call it the 5-number summary? Well, that's because there's 5 numbers. 1, 2, 3, 4, 5. 5-number summary. The next thing we'll talk about here is a box plot. I think we've seen box plots before. Those were popular back in the those standardized tests that you take through the younger grades. I think you may have seen box plots before. In fact, you may have known them as box and whisker plots. But guess what, folks? We're not calling them box and whisker plots anymore. You want to know why? Because we're not in kindergarten anymore. We're calling them box plots. Okay, so a box plot is just a graph of the 5-number summary, and I'll show you an example right above this 5-number summary definition. We're going to have a point at the minimum, a point at Q1, a point at the median, a point at Q3, and then a point out at the maximum. Okay, so we've got those 5 numbers will be marked on a number line. It says the box part of the box plot spans the quartiles. So a box actually spans the quartiles and shows the spread of the central half of the distribution. So that box that we draw around the quartiles shows the spread of the central 50% of the data. The median is marked within the box, usually with a vertical line like that. And then we have lines that extend out to the max and to the minimum from the box. And there you have it, folks. That's a box plot. Okay, let's jump down to an example here. We're going to go back to our friend, the McDonald's beef sandwich distribution. And the fat content data from that previous problem is sorted from lowest to highest. So I kind of helped us out here by sorting it from lowest to highest. We're going to find and interpret IQR for this distribution. Okay, so first, in order to find IQR, we need to know where the median is. And let's just, for a refresher here, 1, 2, 3, 12 different values in this distribution. Because we have an even number, our median is directly between the 6th and the 7th distribution. So our median, again, is 26. Now, Q1, or the first quartile, is the median of the values to the left of the median. So this is the median of the entire distribution. Q1 is the median of the left-hand side. Well, I have 6 values there, so the median of those 6 values will be between the 3rd and 4th observation. So that means that Q1 will have to be the average of 19 and 23, and that's 21. So there's Q1. Q3 will be the median of the right-hand side of the distribution, and I also have 6 observations there, so we're going to go smack dab between number 9 and 10, and take a look at that. They're the same, both 29. So we have 29 as our Q3. Remember, these are all measured in grams of fat. I'm just going to put my units there so nobody claims that I'm shortcutting too much. So now we're going to find IQR, and again, I told you that's a simple calculation. IQR is just Q3 minus Q1. So it's 29 minus 21. So that means IQR here is 8 grams of fat. Okay, so we found IQR. Now let's go ahead and mention something about its interpretation. The IQR of the distribution is 8 grams of fat, which means that the range of the middle 50% of the distribution is 8 grams of fat. Okay, let's move on. I hope some of you are really happy by the next topic we have here. I have a test for outliers. And so far in this course, we've been really wishy-washy in our treatment of outliers. We've said, oh, this observation might be an outlier. It might be an outlier. We haven't really defined what an outlier is, but today we will now have a definition for that. And here's our test for outliers. It's called the 1.5 times IQR rule. And we're going to call an observation an outlier if it falls more than 1.5 times IQR above the 3rd quartile or below the 1st quartile. So let me kind of draw that out in an equation, and then we'll do an example. Okay, so we're going to find out what the value for Q1 minus 1.5 times IQR is, and if we have observations that are less than that, we're going to call them outliers. They're outliers on the left side of the distribution. We're also going to take Q3 and add 1.5 times IQR. If we have any observations that are greater than that, we're going to call them an outlier, and those would be outliers on the right-hand side of the distribution. Okay, so let's, we might as well practice this new definition by looking at the McDonald's beef sandwiches yet again. So the first thing it says here is, are there any outliers in the distribution of fat in McDonald's beef sandwiches? Sketch the box plot for the distribution. So first thing we're going to do is see if there's any outliers, then we'll sketch the box plot. Now I know I need this 1.5 times IQR number, so I'm going to go ahead and calculate that first. IQR was 8 grams of fat. 1.5 times 8 is 12. So there's my IQR. It's 12 grams of fat. All right, now in order to determine whether or not we have any outliers, I need to check both the minimum value in the distribution and the maximum value in the distribution. I'm going to do that by finding both boundaries for outliers. The lower boundary for outliers is Q1 minus 1.5 times IQR. Q1 was 21 grams of fat, and we're going to subtract 12. That's our 1.5 times IQR, and that gives me 9 grams of fat. So I'm going to go back up and compare that to the distribution. If I look right here, 9 grams of fat was our minimum. So if 9 grams of fat is the minimum, is that an outlier? Well, no, because it's only an outlier if it falls more than 1.5 times IQR below the first quartile, and this is exactly 1.5 times IQR below the first quartile. So it has to be actually outside of it. Anything less than 9 would be an outlier. Okay, so now let's look at our upper boundary. And the upper boundary is the third quartile, Q3, plus 1.5 times IQR. And the third quartile was 29 grams of fat, and we have to add 1.5 IQR, or 12. So that gives us a total of 41 grams of fat. And that is our upper boundary for outliers. So let's compare that to the distribution. Well, our maximum was that gut buster of 43 grams of fat. So that is greater than Q3 plus 1.5 times IQR. That means our max is an outlier. Okay, so we've used the 1.5 IQR rule. We've determined that the max is an outlier, but the minimum is not. So let's go ahead and plot the box plot for this distribution. We have our minimum at 9. We have Q1 at 21. We have our median at 26. We have our Q3 at 29. And then our max was 43, and I'm going to mark that 43 as an asterisk because we are claiming, hey, that's an outlier. So I do need to look to see for the right-hand line on my box plot, I need to see what that value should be. Well, the next observation below 43 was 31. So I'm going to mark 31 on my number line. So let's go ahead and take a look at this. There's our box plot, and don't forget that this is the min, this is Q1, this is the median, this is Q3, and then this is the max. Again, the box plot shows us the 5-number summary. And there's just one thing here I'm bothered by, folks. This line right here, you deserve better. That bad boy should be going right through. Now we can move on. Now that's much better. I said 22, I meant 21. Okay, yeah, that's great. So I promised you that I would show you how to create a box plot on the Ti-Nspire, so I'll do that now. We're not going to be drawing graphs by hand very often. We'll do it a few times to get the hang of it, and then maybe occasionally if we're doing a test or something. But creating them on the Nspire is really easy. I have open here a list and spreadsheet page. I already have the distribution entered. Let's just make sure all 12 values are there. Sure enough, there they are, sorted from smallest to largest, and it's labeled with the name fat. So what I'm going to do is I'm going to add a page to this document. I'm going to add a data and statistics page. And right now those dots are just kind of floating around there with no context. So I am going to add a variable to the horizontal axis and give it some context. There it is. By default, we get a dot plot. If we'd like to see a box plot, all we have to do is go Menu, Plot Type, Box Plot, and bang, there's our box plot. And wait for it, there it is, bang, our outlier shows up. Remember I told you that the Ti-Nspire uses the same definition for the quartiles as we do. So we're going to see Q1 is 21, Q3 is 29. Again, this is kind of a nice feature of the Nspire. You can hover over your box plot and it'll tell you all these different values. We got the minimum of 9, the Q1 value of 21, the median of 26, Q3 value of 29. The observation that is just the one observation lower than the outlier is 31, and then we have our outlier separated from the box plot at 43. That's it, folks. We're going to shut it down, and page 3 will start up with a new video. So